On August 1st, the National Oceanic and Atmospheric Administration released its updated monthly outlook for August 2026. The document is called the August 2026 Monthly Outlook Update, and in the headline line describing what had changed from the previous outlook, NOAA used a specific phrase that I want to read to you. Substantially changed. NOAA does not use that phrase lightly. Monthly outlook updates are incremental by design. They incorporate new observational data and model runs, but the fundamental character of a monthly forecast does not typically change dramatically from one update to the next. When the government's climate forecasting agency describes a monthly outlook as substantially changed, it means something meaningful has shifted in the atmospheric data that required a meaningful revision to the forecast. What changed was the behavior of two major atmospheric climate signals, the El Nino Southern Oscillation and the Madden-Julian Oscillation, and their combined effect on the large-scale pressure patterns that govern every aspect of American weather for the rest of this month. Here is what NOAA's updated outlook now shows. Above normal temperatures are favored for the western and southern two-thirds of the continental United States. High confidence, greater than 50%, probability of above normal temperatures across the southern plains. High confidence of above normal temperatures along coastal California. The Northeast and Mid-Atlantic are forecast to be active with storm systems. The northern plains have an equal chances designation. The models do not agree enough to call the temperature direction confidently. And a trough crossing southern Canada early in the month could graze the northern plains and Great Lakes with cooler, more active conditions. And then there is the piece that Direct Weather, one of the private extended range forecasting services, is calling one of the most active weather patterns for the Great Lakes, Ohio Valley, Mid-Atlantic, and Northeast in recent memory, driven by a storm track that is being organized by the same climate signal that is heating the South. This is the pattern shift, and understanding why it is happening requires understanding what the Super El Nino has done to the atmosphere over the past several weeks, because what it has done is genuinely unusual, possibly unprecedented for this time of year. Let's go. Let me explain what a substantially changed forecast actually means in physical terms, because the atmospheric mechanism behind this shift is something I want to make sure you understand. The El Nino Southern Oscillation, ENSO, is the periodic warming or cooling of a large stretch of the equatorial Pacific Ocean that profoundly influences weather patterns around the globe. During El Nino, the eastern and central tropical Pacific runs warmer than average. That warmth generates a massive organized convective complex, a vast region of rising air and rainfall that shifts the atmosphere's fundamental circulation patterns. The jet streams respond, the storm tracks respond, the position and strength of ridges and troughs across the northern hemisphere respond. El Nino is the most powerful natural climate driver on annual timescales. The current event is not a typical El Nino. As of last week, the benchmark Nino 3.4 region of the equatorial Pacific was running 1.3 degrees Celsius above normal, classifying the event at moderate strength by current measurements. But the trajectory is what matters. Severe weather. Europe's most recent analysis, published July 28th, documents that forecast models are now projecting the event reaching above plus 4 degrees Celsius anomaly in the October through December period. An intensity classification that moves this beyond strong El Nino into what climatologists call an extreme El Nino. NOAA's own extended probabilistic guidance gives a 97% likelihood of El Nino persistence through spring 2027. And severe weather. Europe's analysis contains a phrase that stopped me when I read it because it is the clearest possible description of what has happened to the atmosphere over the past several weeks. They wrote, "When meteorologists say the winter pattern is locked in, they mean the event has forced the atmosphere into what scientists call an atmospheric standing wave, an almost stationary planetary scale. Pressure structure sustained by a massive, persistent ocean heat anomaly that the atmosphere has no near-term mechanism to self-correct. An atmospheric standing wave, not a weather system that will pass in a week, not a pattern that will reset in a month. A planetary scale pressure structure that is being sustained by the ocean itself, by the enormous thermal inertia of a massively warm equatorial Pacific. And that the atmosphere cannot correct on its own until the El Nino begins to fade, which NOAA does not expect before spring 2027. This is what is changing everything, not a single storm, not a frontal passage, not a heat dome that builds and then breaks, a standing wave in the atmospheric circulation that divides North America into multiple, sharply different weather zones, and that is going to maintain those zones for months, not weeks. Let me explain the Walker cell, because it is the atmospheric mechanism through which El Nino exerts its influence, and understanding it makes everything else in this forecast more intuitive. In a normal year, the Walker cell is a large-scale atmospheric circulation pattern in the tropical Pacific. Warm water in the western Pacific drives rising air, which flows eastward at altitude, descends over the cooler eastern Pacific, and returns westward along the surface. This circulation pattern is partly why the Western Pacific is so rainy and warm. The rising air brings moisture to Indonesia and Australia, while the Eastern Pacific is relatively cool and dry. When El Nino develops, the Eastern and Central Pacific warms dramatically. The location of that rising air shifts eastward. The Walker cell essentially reverses its character in the Eastern Pacific, rising air over areas that are normally dominated by sinking, and sinking air over areas that normally see rising. This reorganization of tropical circulation forces changes in the mid-latitude jet streams, particularly the Pacific jet stream that governs North American weather, shifting its position, strengthening it, and locking it into a different configuration than it occupies in a neutral year. Severe weather. Europe specifically describes this year's event as having completed its early stage of Walker cell reorganization and now propagating outward into the mid-latitudes that govern U.S. weather. In plain language, the tropical signal has graduated from the ocean to the atmosphere. It is no longer primarily an oceanographic event. It is now actively driving the atmospheric circulation that controls your weather. The mid-August MJO re-intensification that NOAA flags in its August outlook, the Madden-Julian oscillation, is a global wave of tropical rainfall and wind that circles the Earth roughly every 30 to 60 days, is the specific near-term atmospheric feature that NOAA credits for the substantially changed outlook. When the MJO re-intensifies in phase A6 in the Western Pacific, it reinforces the El Nino forcing on the North American pattern. The ECM, WF, and GEFS model guidance that NOAA cites both support above-normal mid-level heights across most of the lower 48 throughout August, but with a critical exception in the northeast and along the Canadian border, where the low-pressure tendency that El Niño's August atmospheric signature creates becomes increasingly evident in the second half of the month. This is the pattern that is changing, and it is changing in ways that affect different parts of the country very differently. Let me walk you through what this means region by region, because the split flow pattern that the Super El Nino is imposing on North America is genuinely heterogeneous, not one story. Several simultaneous and very different stories happening at the same time across different parts of the country. The Southern Plains and South Central United States. This is the region where NOAA expresses its highest confidence. The combination of El Nino composite patterns, observed trend, and dynamical model agreement all point in the same direction. Above normal heat with greater than 50% probability for most of August. Oklahoma and Texas have the highest confidence signal for significantly below average precipitation this month. Direct Weather's August forecast says explicitly, the combination of limited storm activity and persistent high pressure is expected to support prolonged stretches of hot weather. One or more notable heat waves could develop across the central and northern plains. Dry soils make this worse. When the ground has no moisture to evaporate and cool the surface, more of the sun's energy goes directly into heating the air above it. The drought conditions that have been developing across portions of the southern plains through the summer of 2026, conditions that the direct weather forecast acknowledges with its below-average rainfall outlook for Oklahoma and Texas, mean the heat over these areas is going to be reinforced by land surface feedbacks, not just by the atmospheric pattern overhead. For people in Oklahoma, Texas, Kansas, and the adjacent Great Plains states, August is going to be hot. How hot depends on whether any troughs can edge southward from Canada and provide temporary breaks. But the baseline forecast is for a consistently hot month with limited storm relief and continued drying. Coastal California. NOAA specifically calls out coastal California for high confidence of above normal temperatures in August, citing a combination of predicted mid-level ridging and observed above normal sea surface temperatures in nearshore Pacific waters. California's coast has been running anomalously warm this summer, and the atmospheric pattern NOAA is forecasting for August reinforces rather than relieves that warmth. For inland California, the Central Valley, the Sierra foothills, the concern is fire weather. The combination of above normal temperatures, continued below normal precipitation, and any offshore wind events that can produce critically low humidity creates the conditions that have driven California's most destructive wildfire seasons. The pattern through August does not improve those conditions for the inland areas most vulnerable to fire. The Northeast, Mid-Atlantic, and Great Lakes. This is the most interesting and perhaps the most significant regional story in the August forecast, and it is the one that directly reflects the El Nino atmospheric standing wave pattern at mid-latitudes. Direct Weather describes this region as facing one of the most active weather patterns in the Great Lakes, Ohio Valley, Mid-Atlantic, and Northeast in recent memory. That is a striking characterization for midsummer, which is normally the quietest time of year for organized severe weather in the eastern United States. The storm track that is being forecasted for this region through August, driven by the low-pressure tendency that El Nino imposes on the eastern United States, reinforced by the MJO re-intensification in mid-August, is going to bring repeated rounds of rainfall, cloud cover, and severe weather potential to communities that are already dealing with saturated soils from the relentless early summer pattern. Severe weather. Europe's ECMWF ensemble analysis for mid to late August explicitly shows increased rainfall over the eastern and northeastern United States. The precipitation anomaly for this region is positive, wetter than normal, while the south-central U.S., upper Midwest, and Pacific Northwest face drier conditions. This sets up a sharp precipitation gradient across the country, a wet, active, stormier pattern in the northeast, and a dry, hot, high-pressure-dominated pattern in the south and central U.S. That gradient, when it is sharp enough, when the storm track is sufficiently organized, also creates the conditions for severe weather development along the boundary between the wet northeast and the hot south central. It is not identical to the spring severe weather pattern, but it rhymes with it. For people in the northeast, August is going to feel more active than a typical late summer. Rounds of heavy rain, storm systems, and periods of active weather are more likely than the quiet heat dome August that the southern plains are going to experience. This is not exclusively good news. The existing saturated conditions across New England and the mid-Atlantic from the summer's earlier active pattern mean flooding risk from heavy rain events remains elevated, but it does mean temperatures in the northeast are likely to remain closer to normal than in the south. The Pacific Northwest and Northern Rockies, dry. That is the one-word forecast for the Pacific Northwest in August, and it is a concerning one. The super El Nino pattern that is driving the active storm track in the northeast is simultaneously establishing drier than normal conditions in the Pacific Northwest, consistent with both El Nino composite patterns and with the ridge-dominant signal that has been present over the Pacific Northwest and Western Canada through much of the summer. Pognick's August analysis describes the most serious overlap of heat, dry fuels, and wildfire danger as expected in southern interior British Columbia, northern Canada, northern Manitoba, northern Ontario, and Quebec. For the continental United States, the fire threat across the Northwest remains elevated through August. The Spokane wildfire disaster that I covered in detail earlier this week is a preview of what the Pacific Northwest fire season looks like when dry, hot conditions intersect with a spark. The conditions that enabled that disaster are not resolving in August. They are being maintained. Smoke from Pacific Northwest and Canadian wildfires is going to be a cross-border weather story throughout August, with smoke forecasts showing periodic transport of smoke southward into the western United States and eastward across the northern tier. Air quality in the northern states and the Pacific Northwest is going to be a recurring public health concern through the month. The southwest and southwest monsoon. This is where the forecast is most different from what most people would expect, and where the El Nino signal produces its most counterintuitive effect on the summer pattern. Normally, the southwest monsoon, the seasonal shift in wind patterns that brings moist air northward from the Gulf of California and the Gulf of Mexico into Arizona, New Mexico, and surrounding areas, is driven by the subtropical high-pressure ridge that builds over the Four Corners region in late June and July. El Nino disrupts that ridge. When El Nino is present, the subtropical high tends to be displaced or weakened, and the resulting pattern allows more substantial moisture transport northward into areas that are not traditionally the monsoon core: Utah, Wyoming, Nevada, eastern Idaho. The August 2026 forecast from multiple sources, UNOAA, Pognick, OpenSnow, shows the southwest monsoon is more active than normal, potentially bringing drought relief, but also dangerous flash flooding to the Four Corners region and its surroundings. Direct weather expects above-average precipitation across much of the West Coast, the Four Corners region, Nevada, and southeastern California. NOAA explicitly notes that the southwest monsoon may be more active under the current El Nino configuration. For communities in the Four Corners region that have been dealing with drought, and much of the southwest has been, any monsoon rainfall is welcome. But the combination of dry, compacted soils that absorb water slowly and the intense convective rainfall that southwest monsoon thunderstorms can deliver creates ideal conditions for flash flooding. The arroyos fill instantly. The desert hardpan sheds water rather than absorbing it. Communities along desert creek beds and in canyon areas need to be aware that monsoon rainfall in August, even welcome drought relief rainfall, can produce life-threatening flash floods. Let me address what all of this means for the tropical weather pattern, because August is the heart of Atlantic hurricane season, and I know it is on a lot of people's minds. The current El Nino signal at Nino 3.4 of plus 1.3 degrees Celsius, moderate strength, is providing increased vertical wind shear across the Atlantic main development region, which historically reduces the number of tropical cyclones that form and intensify in the Atlantic during El Nino years. Direct Weather's August outlook specifically acknowledges that El Nino patterns favor fewer tropical systems, affecting the Gulf Coast and Southeast. NOAA's extended seasonal outlooks have reflected this reduction in Atlantic tropical activity as a consequence of the ENSO signal. The caveat is the one that exists every year. Fewer storms does not mean no storms, and the Gulf of Mexico's sea surface temperatures remain anomalously warm in 2026. Any tropical system that does develop and enter the warm Gulf waters will have access to an exceptional amount of thermodynamic energy. The combination of fewer than average storms with potentially rapid intensification for any system that does form is the risk profile for the Atlantic in August and September. For the Pacific, the ENSO signal has the opposite effect. El Nino tends to shift typhoon formation eastward in the western Pacific, giving storms more time over warm, open water, enabling more rapid intensification, and producing more Category 4 and 5 events than neutral or La Nina years. The Western Pacific typhoon season through 2026 has already demonstrated this dramatically with Super Typhoon Sinlaku in April and Super Typhoon Bavi in July, both reaching Category 5 intensity and striking American territory in the northern Mariana Islands. The peak of Western Pacific typhoon season, August through October, is still ahead. The ocean conditions that produced Sinlaku and Bavi have not changed. If anything, they are warming. The pattern that the Super El Nino is imposing on the Pacific typhoon season is not going away. Let me close with what the bigger picture of this August pattern shift tells you about what is coming for the rest of the year. Severe Weather Europe's analysis is explicitly forward-looking in a way that I think deserves your full attention. They describe the Super El Nino as now driving a split flow pattern that begins in late summer and strengthens into fall and especially winter. The atmospheric standing wave that is being established by the El Nino Walker cell reorganization is not a temporary August feature. It is the preview of the fall and winter pattern for the entire country. The split flow pattern, a deep Pacific trough paired with a powerful Canadian ridge forming what Severe Weather Europe calls an atmospheric highway, is the configuration that drives the most distinct temperature and precipitation anomalies in a Super El Nino winter, mild weather locked in the northern tier, an active storm track across the southern United States. This is qualitatively different from a moderate El Nino winter. The raw strength of this event drives its signature more forcefully onto the atmospheric circulation than typical events, producing more extreme anomalies, more clearly defined regional differences, and more persistent departure from normal conditions. NOAA's confidence signal is already elevated for the southern plains, consistent with this pattern. The northeast storm track that Direct Weather is describing for August is consistent with this pattern. The Pacific Northwest dryness is consistent with this pattern. The southwest monsoon enhancement is consistent with this pattern. The weather shift that is happening right now is not just an August story. It is the beginning of a seasonal transition that is being organized by the most powerful climate driver on annual timescales at a strength level that is trending toward historically extreme territory. What you see in the forecasts for August is the opening chapter of a story that is going to unfold through fall and well into winter. Here is what I need you to understand from all of this. If you are in the southern plains or south central United States, prepare for a hot August with limited precipitation, high confidence heat and drought conditions. Have your heat safety plans in place. Know where air conditioning is. Check on vulnerable people in your community. If you are in the Northeast, Mid-Atlantic, or Great Lakes, an active storm track is coming through the second half of August. Monitor forecasts for heavy rain and flooding. The saturated soil conditions that have characterized this region's summer remain in effect. Flash flood risk from heavy rainfall events remains elevated above normal. If you are in the Pacific Northwest, fire weather, dry, hot, smoke-filled. The conditions that produced the Spokane fire disaster are the conditions that will characterize much of August in the Northwest. Know your evacuation zone. Have your go bag ready. If you are in the Four Corners region, monsoon activity, drought relief, and flash flooding risk simultaneously. Know your local flash flood geography. Turn around, don't drown. And for everyone, understand that what we are living through right now is not the weather of a normal summer. It is the weather of a developing Super El Nino, classified at +4 degrees Celsius anomaly in extended forecasts, driving an atmospheric standing wave that the ocean has no near-term mechanism to correct. This pattern is going to be with us through fall and into winter. The shift that is happening in August is the shift from a pattern you might call active but manageable to a pattern that is going to define the rest of this year. Stay informed, stay prepared, subscribe and turn on notifications. Don't be scared, be prepared. Stay safe out there.